This conference will now be recorded. This conference will now be recorded.
Okay, so let's quickly take a look at what we did on day 3. So day 3, we started with we looked at our measure phase tool, that is process capability. So it's been like about 1 week, so I just have to refresh you about process capability. So we learned that the process capability is nothing but whether your process has the ability to meet the customer requirements, right? And how do you measure it? You measure it in CP and CPK, right? So CP formula, we learned that, so we took that example of the 3 trainers, right? The 3 trainers. So CP can be calculated. The formula is USL minus LSL divided by 6 times standard deviation. And in case of CPK, we have to calculate 2 values, that is CPU and CPL. So it's like USL minus mean divided by 3SD, and then CPL will be mean minus LSL divided by 3SD. So we did this in detail, the calculation, we know how to go about the calculation. And coming to the trainer example, so we had the mean and standard deviation given to us for all the 3 trainers, and then we calculated the CP and the CPK. Coming to the result interpretation, I told you all that the ground rule is that both CP and CPK should be greater than 1, right? Only then we can call the process as potentially capable as well as actually capable. So in the example, we saw that last week what we discussed is only trainer 1 was capable, right? So we had to take a practical action on the trainer 2 and the trainer 3. Next, we actually went to some of the simple tools in the analyze phase. So we started with our analyze phase last week. We looked at the basic problem solving tools. So I did the cause and effect, or the fishbone, or the Ishikawa diagram. So we did an exercise. So we know very well that the cause and effect diagram it helps you all to brainstorm all the possible causes for a problem under the 6 M's. So we know what are the 6 M's, that's man, machine, method, material, measurement, and mother nature. Next, you cannot work on too many causes. So you need to use a prioritization tool, that's the Pareto chart. So the Pareto chart helps you to prioritize the key causes responsible for the problem, right? So all of you know how the Pareto chart works. So we know very well that it works on the 80-20 rule, or the Pareto rule, which states that 80% of the problem just comes from 20% of the causes. And finally, we do the root cause analysis for the prioritized causes, and we can use the very famous 5I analysis. So last week I showed you an example of how the 5I analysis works, right? Now, after the 5I analysis, we use the CAPA, that is, we take the corrective action and the preventive action. After which we moved on to critical to quality. So I told you about the CTQ tree. Maybe I can just quickly open up the diagram of the CTQ tree once more, so that you can remember. So the CTQ tree, it actually helps you to convert your customers' needs, vague needs, into key drivers, into critical metrics or critical CTQ requirements, which are easier to measure, right? So if customer says, I want a coffee that is good, we need to find out what is the meaning of what is good for him, and then arrive at easier to measure critical metrics. Okay. So this is the CTQ tree, which helps you to translate broad customer needs or vague customer needs into key drivers into specific and measurable CTQs. Okay, next, after this, we moved on to the concept of cost of quality. So we know that cost of quality includes both the money spent in order to meet quality, to keep up the quality, as well as it's also the money spent in case of not meeting the quality. So we know very well that it can be divided into preventive, money spent on preventing a failure. So that's example is training and improvement programs, things like preventive maintenance. Appraisal is the cost of checking, QC, inspection, audit, testing, whatever you call it, basically cost of quality conformance. Internal failure cost is money spent before the product or the service reaches the customer. Cost of rework, rejects, scrap, everything comes under this. External failure is money spent after the product reaches the customer. Examples include warranty claims, recalls, returns, repairs, etc. And over and above this, we know that the brand name or the reputation of the company goes for a toss. And lastly, we had time to discuss one more concept, that is RTY. So I showed you how to calculate this RTY, which is roll throughput yield. So it's a metric which is rolled up at a process level. So you all know what is FPY, right? First pass yield. So the formula of RTY is nothing but it's like FPY, it's the product of all the individual FPY. So I told you that if FPY is at a sub-process level, right, then RTY is a rolled up metric which is at a process level. So we took that example. Let me quickly open up the example so that you can relate to it or remember it. I think we took that example of the payroll, right? Yes, we took this example, calculate the RTY. So I showed you in Excel how to do it. You have to convert the numbers into percentage and then take a product to get the RTY. Okay, so that's all we did last week, right? So today let's look at the agenda for day 4. Okay, so today, guys, first of all, I have a hard stop at 2 o'clock. So next week, I'm not sure whether you have been informed about the timings of the next week. Okay, so today we will just be doing the session for about 2 hours. I have a hard stop at 2 o'clock. And then next week, we'll be doing it from 12 to 3, next Sunday, 12 o'clock to 12 to 3 p.m. All right, so today we will start off, we'll continue with our analyze phase, and we will look at one of the complex tools of the analyze phase, that's TOH. Okay, so it's a big tool. So I think a couple of you already know that what the abbreviation stands for. Do you know what the abbreviation stands for? TOH? Kavya, the only problem is, let's see, I will let you all know, because I have trainings in the evening. So again, today I have a training in the evening. So I'll definitely, I'll talk to Saurav and I can let him know. Okay. So soon we will, get back to you with the timings of the next week. Okay, so the TOH stands for the very famous test of hypothesis. Most of you would have heard about the test of hypothesis. Okay, so today we are going to be looking at this analyze phase tool, which is a little bit complex. So it may take about 1 hour for you to understand this test of hypothesis itself. Sure, Kavya. I will just keep him updated. All right. So the test of hypothesis, what happened, Kavya, yesterday, I had a session till around 12 o'clock in the night because it's for international participants. So during that time zone, people from the US, Canada, and the rest of the world join. So by the time I complete this training, have my dinner and sleep, wrap up and sleep, it's like quite late. So today I could not do that 10 to 1. So that's the reason. Anyway, I'll keep you posted. We'll keep you posted about the next week. Yep. All right. Okay. So how many of you know about the test of hypothesis, which is a little bit complex tool? So you will take around 1 hour to understand this. Anybody who's already come across this or studied this during your engineering or your MBA curriculums? So nobody knows about test of hypothesis? Okay, just trying to get an idea if anybody is already familiar with the test of hypothesis. All right, no issues, guys. So just wanted to know whether you guys are already aware of this. Else, I'll do as usual. I'll start from the basics. No issues. Okay, now first let's begin with, let's start right from the scratch. So what do you think is a hypothesis? What comes to your mind when you hear the word hypothesis? Let's begin from there. Start discussing what is a hypothesis. What comes to your mind when you hear the word hypothesis? Okay, so guys, I just had to mute myself because there was a vendor who was passing by. Right. So coming to hypothesis, so Arjit says it's a typical situation. Like Piyush says, yes, it is an unproved theory which has to be proved. So basically, it's like an assumption. Yes. So we don't know whether it is true or false. So maybe I'll just put a simple definition over here. So I can just I've just put it in our Excel sheet. So what is a hypothesis? Basically, a hypothesis is an assumption or a claim. Okay, or maybe I can add the word theory. Yes, so hypothesis is an assumption or a theory which is not yet proved. Okay, so it may be true, it may be false. So when we say an assumption or a theory which is not yet proved, that means it may be true or it may be false. Now, how do we conclude whether it is true or false, right? So like Saurav says, we have to make the decision whether it is true or false. We don't know whether it's true or false because it's just an assumption. So how do we do that? We do the test of hypothesis. So you can see that this is where the name comes from. Why is it called as the test of hypothesis? Because we actually do a test of hypothesis to validate the claim based on data. Okay, so when I say data, this is purely data driven. Nobody knows what is the truth, so we purely go with the data, and it is a data driven approach. Okay, so I'll give you the roadmap. So I don't want to put too many things over here. Maybe we'll go step by step. So we will just paste in the notepad what is a hypothesis. So we will go step by step. So we all know that it's an assumption or theory. It may be true or it may be false, and the test of hypothesis is done to validate the claim based on data. Yes. So far you know this much about the test of about the hypothesis. Yes. Now next we will look at the roadmap, a high level roadmap of TOH, how the TOH has to be done. So it's like, first we will have a hypothesis or a claim. Okay, and next we will be collecting some data for it. So maybe I can use the pen over here. So first we will be having, okay, so first we'll be having the hypothesis, then we'll collect some data for it, and then we'll perform the test of hypothesis, and finally we'll interpret the result to tell whether the hypothesis is true or false. Okay, so this is how it works. so first we'll have a hypothesis. We'll collect some data. We'll perform the test of hypothesis. And interpret the result to conclude whether the hypothesis is true or false. Okay. Now, you may not be able to understand this just by these definitions or what I'm telling you. Yes, Arjit. So I mean, it actually depends on the situation. So what we'll do is we will look at an example shortly. So you may not be able to understand the test of hypothesis because it's a complex tool just by looking at the roadmap. So let's look at an example, and then I will tell you. See, it actually depends on case to case. So if it's true or if it false, then it is different things which are true or different things which are false. The result interpretation is different. Okay, so let me quickly open up an example and take you through the example. So guys, as usual, give me 15-20 minutes or maybe half an hour. You will take some time to understand the complete test of hypothesis. It's a little bit complex. Again, if you understand the test of hypothesis, trust me, this is the only difficult part in the entire Lean Six Sigma Green Belt course. The rest is easy. Even control charts, DOE, which you're going to be looking at next week, it's comparatively easy. If you're able to crack the test of hypothesis, everything else is easy. Okay, so just give me some time. I'll have to go step by step for this. Okay, now first and foremost, I'm talking about a project. Okay, now let's say, first I will just put it in my notepad or in my Excel sheet. Okay, now let's begin with an example of the test of hypothesis. Now let's say a Greenbelt project was done to improve the quality of a training program. Okay, now suppose there was a GB project which was done to improve the quality of a training program. So we did, so anybody wants to volunteer as an operations manager who will be doing or working on this project with me? Yes, okay. Now let's say Arjit and myself. Okay, thank you, Arjit. So let's say Arjit is the operations manager and I am the quality manager. Okay, so both of us are doing a project to improve the training program quality of one training program, right? So Arjit is the operations. So I'm repeating, Arjit is the operations manager. I'm the quality manager. So both of us are doing or working on a project which was done to improve the quality of the training program. Now, after the project is being done, so we have the results and Arjit says that, yes, we have been successful in making an improvement. The new training program is much better than the old training program. But, I go ahead and say that, Arjit, I don't think so. We have made a significant improvement. I think we should have done much better. So I don't think so we can close this project because it's not a good improvement or it's not a significant improvement. Okay. And as you guys know, I mean, I think we have already brought this point. The operations and the qualities, quality team, they never agree to each other. There's always a tiff between the two, right? Operations and quality. So likewise, myself and Arjit can continue to argue. Arjit says, so what is the argument Arjit has? There is an improvement, right? And a substantial or a significant improvement. And I say that there is no significant improvement. Or I can say that the improvement is not significant. There is an improvement, but it is not significant, right? Now, yeah, Arjit is the operations manager, Chitra. So everybody is understood so far, right? So both of us are arguing. Arjit says there is an improvement. Let's close the project. I'm saying the improvement is there, but it's not significant, so we cannot close the project, right? So this is stuck. So both of us can continue to argue, right? We can continue to argue unless we prove it with data. I'm not sure whether you guys have had this situation where there are arguments similar to this, and then one manager says something, the other manager says something, or one department says this is what it is, or other department says, and finally you guys choose to go ahead with data and make the decision. Has it been, I mean, has anybody come across such a situation where you have preferred the data and not just arguing about the situation? Okay, now next, tell me what kind of data can we take over here to prove that the new training program is much better than the old training program? Yes, exactly. We can take some things like this. So we can ideally take the scores before and after the training improvement project, don't you think? Right? So it's like the same batch. They went through the old training program and then they gave the exam, let's say. Yes, the quality score or the exam result, whatever. So it's like they went through the old training program, the same batch gave the exam, and then again they were made to go through the new training program and they took up the exam. Okay, and I have to change this name over here to Arjit because Surya was from the previous batch. All right, can we do this? Collect some data like this. Yes, and then compare. Now, as per the scores, what do you think? Is the new training program much better than the old training program, or how is it? How can you conclude that? Yes, looking at the average. Now, why do you think I've put the average over here? Because in some cases, see, in most of the cases, the person has, increased, or the person has done much better after attending the new training program. But there are certain exceptions, right? Where, for example, in this case, where the person is scored lesser, the second time after going through the new training module, right? So to avoid all this, what I've done is I've gone with the average. Yes, okay. Now there's a clear difference between the average. Okay, so everybody knows how to decide on this. Next, now let's see what is the difference between the two. Let's see what's the mathematical difference between the average scores. So let me just put a difference over here in this cell. So the difference is clearly a 17, difference of 17, correct? Right? Okay, now this is the mathematical difference, right? So everybody knows that the 17 is the mathematical difference. Now let me just quickly change the scores. Sorry guys. So let me just quickly change the scores a little bit over here. Let me just type in a different score over here. I've just changed the mean. Is there a difference, a mathematical difference still? Yes. So there is still a mathematical difference of 0.5. Even a 0.1 is a mathematical difference. But in this case, there is a difference. The new training program is better, right? The average score is higher. But can we conclude there is a significant improvement in the new training program? Yes. So now we know what is the difference between a mathematical difference and a significant difference. In this case, there is no significant difference between the two average scores. Okay. So just wanted you to understand what do we mean by a significant difference. All right. Okay. Next. So I'll just change back the scores so that to avoid any kind of confusion. So everybody understands what's a significant and a mathematical difference. All right. So I'll just put that over here. Significant difference versus a mathematical difference. Okay, next, Before going into the test of hypothesis, okay, so what we are going to be doing is, since myself and Arjit are continuing with our argument, we are not closing the project over here. So shortly what we are going to be doing is we are going to be putting this data and we are going to be doing a test of hypothesis. Now, before even doing that, what we'll do is we'll learn about, yes, Arjit, I have shared it last week itself. Immediately after the session, I've updated for last week. Okay, so even today, immediately after the session, I'll update it. I'll put the test of hypothesis. All right. Okay. Now, guys, before even going to the test of hypothesis, you need to learn some more basic concepts or basic terminologies of the test of hypothesis, like how you learned what is hypothesis. Now, have you guys heard about something called as, coming to the basic terminology, have you guys heard about something called as null hypothesis and alternate hypothesis? Heard about it? Okay, I think this seems to be new for most of you. Yeah, maybe in some engineering, some of you who are engineers, or in some engineering branches, they teach test of hypothesis. Anyway, I'll assume that you guys don't know about it. So what is this null hypothesis and what is this alternate hypothesis? Okay, so let's look at that. So null hypothesis is denoted by a H naught. Okay, so this is the basic terminology of in TOH. So the null hypothesis is denoted by a H naught. So how do we type in a H naught, right? A H naught, a H and 0. And the alternate hypothesis is generally denoted by a H1 or a HA, A for alternate. So in some books, you can see it as H1. The other denotation which is used is HA. Both are correct. So either you can use HA or H1. All right. Okay. Now these are the two hypotheses. Now let's try to understand what is the meaning of these two hypotheses. All right. So let's scroll down and try to understand what is the difference between the two. What is the meaning of the null and the alternate hypothesis? So the null hypothesis states that there is no difference between two samples or two groups of data. Okay, so guys, here is where you need to take some time, or there'll be a slight struggle until you understand what is the null and the alternate. So I just want you to concentrate. I mean, you are concentrating, but very keenly, because if you understand the concept of null and alternate, then you will understand the test of hypothesis. So null always states that there is no difference between two groups or two samples of data. An example of two samples of data or two groups of data is data like this. Okay, so it says that there is no difference. So when I say no difference, no significant difference, right? So just going back to that 79. In this case, so this is the null or the alternate hypothesis. Yes, it is the null hypothesis because there is a difference, mathematical difference, but again, there is no significant difference over here. Okay, so this is an example of a null hypothesis. Again, going to the alternate hypothesis, what does the alternate hypothesis state? It states that there is a clear difference or a significant difference between two samples. Okay, so what I'll do is, to avoid any confusion, I'll add the word significant. So null states that there is no significant difference between the two samples, and alternate states that there is a significant difference between the two samples. Right? And what I'll do is I'll add both of these points to the notepad. Okay, so null clearly states that there is no difference, no significant difference between the two groups or two samples of data, and alternate states that there is a significant difference between the two samples of data. And I'll also put that this is the null and this is the alternate. So it's actually a small a. Okay, so you have it in the notepad. Okay, yes, exactly. Good question. Okay, good question from Arjit. How do you conclude what is a significant difference? So I want everybody to pay attention. Good question from Arjit. Remember, guys, we learn a lot from each other's question. Now, the next question which comes to your mind is, how do you define which is significant, right? Now, significant can be different for different people, right? It is subjective. Exactly. Okay, so Arjit, shortly I'll tell you about that. So let's change our numbers back. So I think it was 62.5 or something. All right. Now, in this case, we have a difference of 17. Okay. Now, what does Arjit say? That it is significant. And then what do I argue? That this difference of 17 is not a significant improvement. So we can be subjective. This is very subjective. Now, what is the next thing is, what is a threshold to conclude whether it is a significant improvement or no? So everybody is getting it. Now, how can we conclude whether this 17 is a significant improvement or no? Or what is a threshold? Okay, so just give me a few minutes. I'll tell you something. We actually calculate something called as p-value. You guys would have heard about it in TOH, which will help us in concluding whether it is significant or no. Okay, so answering your question, Arjit, at this point of time, so there is something called as p-value, which will be, trying to understand shortly. So that will help us. This value will help us. This will be calculated purely based on the data, and this value will help us to conclude whether the improvement is significant or it is not significant. Okay. Now, before that, so Arjit, at this point of time, I'm just answering your question, but give me 5-10 minutes. I'll go step by step to this particular field. Okay. All right. Now, the next thing is, so let's put the two hypotheses. Okay. So what are the two hypotheses? So one of the hypotheses is there is no significant difference between the average scores. Okay. So one of us is saying that there is no significant difference between the average score. That means we are saying that this 17 is not significant, correct? And so what hypothesis is this? Let's go step by step. What hypothesis is this? There is no significant difference between the average scores, or this 17 is not significant. Yes? So I'm giving you some practice on how to choose the different hypotheses. Whichever stands for equality, right? So null, or it's nothing but it's standing for equality, right? So I'll also put that point into the notepad, that null always stands for equality. H naught stands for equality. This is universal, anywhere, right? Null always stands for equality, and alternate is for difference. It's always for a difference. All right. Okay, great going. So far, so let me just scroll up and look at the answers. Yes, all of you understand that this is the null hypothesis. Now, where should I paste this? Is it me who is supporting the null hypothesis, or is it Arjit who's supporting the null hypothesis? Think carefully and tell me. Piyush, are you sure? Yeah. Okay. So the null hypothesis, I'll paste it next to myself. Yes. So I'm supporting the null. I'm saying that there is no significant difference. Yes. I'm saying that there is no significant difference between the average scores. 17 is not significant. Right? For me, 17 is not significant. And now automatically, so let me just, okay, so Chitra, I'll just repeat the question. So I just put one of the hypotheses that there is no significant difference between the scores. That means the 17 is not good enough. We have not improved significantly. So I was just asking whether what hypothesis is this, and everybody told null. And then I was asking them whose argument is this, whether I'm supporting this or is it Arjit who's supporting this, who's telling this. Yes, so I'm saying that there is no difference between the two scores. Yes, now automatically what Arjit says is the alternate. We all know that because that is the one which is left, right? And so Arjit is saying that there is a significant difference between the average scores, correct? So he's telling that this 17 is good enough. We can close the project. Right? Sure, Arjit, no problem. So guys, I know it will take some time. So I'm giving you some practice. Maybe if I give you a few more examples, you will be able to understand. Okay, so what I'll do is I can just try to copy paste this. It's in cells. Again, I don't know how it will come in. Yeah, it is coming out. Yes. So both of us, our arguments are here, right? Now, the next thing what we need to do, so everybody's understood how to take the null, and so I was just giving you some practice on how to choose the null and how to choose the alternate. So whichever, it's simple, the rule is simple. Whichever is for equality, no significant difference, that you can choose as the null. And whichever is for significant difference, then you can choose that as the alternate. Very easy to do that. Okay, now what I'll do is we will actually conduct the test of hypothesis, right? So I can just show you a screenshot of the result. So let me just do that. Okay, so what we can do is we can actually put the data into a software like Minitab, and so I have the test results already with me. So just quickly looking at the roadmap, going back to the roadmap, what was our roadmap? So first you will have the hypothesis, correct? Right? So we have the two hypotheses. Let's put, so we have decided, have we decided? Yes. H1 and H0, we have it. Do we have the data? What's the data which we have? We have the scores, correct? And then now we are performing the test of hypothesis, or I already have the result. The next thing is we are going to be interpreting the result to conclude whether the hypothesis is true or false. So I'll just show you that this is nothing but an example of a two-sample t-test. Why is it called as two-sample t-test? Any idea? You would have heard about this, or you would have come across these names. One sample t-test or two sample t-test. Some of you would have seen this in some books. Why do you think it is called as two sample? T-test is nothing but test of hypothesis. Simple, because it has two samples. It's comparing two samples, correct? Scrolling up, it is comparing these two groups of data. So that's why it's called as a two sample t-test. Okay, now let's quickly look at this results over here. So let's see what is Minitab. So this is from Minitab, guys. I've pasted the result. So it is comparing the before the project and after the project. So what do you think is N over here? Yes, N is nothing but the sample size. Scrolling up, we have 11 values over here, right? So you can see the sample size over here. So it is 11 over here. Next, the same mean is calculated, correct? So what does Minitab give us? The sample size, which is 11, and then the mean is calculated, okay? And then even the standard deviation. Last week we learned about how to calculate the standard deviation, last week or a week before that, I don't remember. So the same way Minitab is also calculated the standard deviation of the data. And then there is also something called as standard error of mean, which we don't really look into. Okay, we don't make any conclusions based on this. We can actually ignore this. And it clearly gives the difference between before the project and after the project. So it is giving the difference between the two means. It's a 17. Okay. And finally, so we don't have to worry about all this. So it's calculated the mean, it's calculated. So guys, one more thing. Anybody who's used Minitab, you will know that Minitab actually throws a lot of values. It does a lot of calculation. Anybody who's used Minitab over here? Yes. So Arjit, you know that it will throw a lot of calculations, but we don't have to. Yeah, Anup and Arjit. So we don't have to worry about all this. We base our conclusion primarily looking at the p-value. Okay, so Minitab, remember guys, in future, even if you download and use Minitab, don't worry, it will show you a lot of things, but you have to look at one of the things. I mean, primarily your conclusion will be based on the p-value. You don't have to worry about the mean or the standard deviation or the standard error of mean, nothing. So your conclusion will be purely based on the b-value. So anybody knows how to go to the conclusion, or how, do you guys remember how to go to the conclusion?
Asha, I have a question. What is the symbol before and after?
Okay, the symbol over here, it's nothing but the mu, the mean.
Oh, okay.
So mu stands for the mean over here, Chitra. So it's just taking a difference between the two means. Mu, sorry, I didn't explain that. It's the difference. Mu stands for the mean over here, and this is taking the difference between the two means, which is a 17.27.
Okay.
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 Guys, I'm not sure whether you can hear the vendor in the background. Just let me know if it's like, okay, they've just passed by. Okay, anyway, we can continue. All right, now we have to base our conclusion primarily on the p-value. So I'm quite sure some of you who already know about the test of hypothesis, you know, you would remember how we conclude. I mean, maybe shortly, if I tell you about how to interpret the result, maybe some, exactly, yeah. So Anup is already remembered, good. So good memory, Anup, like even after so many years, you have remembered, right? So how do we make a conclusion? So this is very important. So if your p-value, okay, so we actually go ahead with a constant. So let me just put it on the Excel over here. Let me make some space in my Excel sheet. Exactly. Okay, so Anup, you're, yeah. So guys, I'll just answer the question one by one. So sort of answering your question, the 0.001, there is a calculation behind that. It purely is coming from the data what we have put, the two groups of data. Okay, so at a green belt level, we don't really have to know the calculation part. But if you guys are interested, at the end of the day, I can share a video with you for the p-value calculation. So today we are fortunate enough to have tools like Minitab who actually give you the p-value based on by the built-in function. So we don't really, but if you wish to know how it is done, I can share a video with you. Okay, now I think there is another question from Lalit. So Lalit wants to know the difference between mean and standard error of mean. So mean is nothing but the average, Lalit, scrolling up. Okay, so mean is nothing but the average over here, and standard error of mean is like, you know, these tools are actually not 100% correct. When I say not 100% correct, the result, because we actually are taking a sample over here, just 11 values, right? So generally they say that you have to take at least 30 sample size. So we are basing our conclusion on just a sample. So that's why we have, you know, Minitab actually gives some room for some errors. So that is what is standard error of mean. Sure. So guys, just I will just put it in my notepad to share that. Okay, so share the link for p-value calculation. Again, you can just like, I mean, like how you guys wanted to know about the manual calculation of, so Saurav, in that video, everything will be there. Okay, and so guys, it's like last week or week before that, you wanted to know the manual calculation of standard deviation. But again, you will never be required to do the manual calculation. We have tools like Excel or Minitab, but it's always good to know how it is calculated manually. So I'll share the link with you at the end of the day. All right. Okay. So now going back to our result. So like Anup said, I'm just going to be showing you how to interpret the result. So it's like we base our result on the p-value, and so if we say that if your p-value is greater than a 0.05, okay, then we conclude that your null hypothesis is true. Okay, the same way if your p-value, so we base our conclusion whether the p-value is greater than or less than 0.5. So if it's less than 0.5, then we say that the alternate is true. Okay, so in this case, the null is accepted and alternate is rejected. Okay, so if the p-value is greater than 0.05, then the null is true, it is accepted, and the H1 is rejected. The same way, if p-value is less than 0.05, then alternate is true, it is accepted, and what is rejected in this case? If we accept the alternate, then what is rejected? Which hypothesis is rejected? So we are accepting the null. Sorry guys. Yeah, for a minute I was confused. Yeah, we are accepting the alternate here. Yes, exactly. What you said is right. So it is accepted and the null is rejected. Sorry, you guys were correct. Yes. All right. So let us go a little bit deeper into this. Okay. So first and foremost, p-value is probability value, sort of. P stands for probability. And why we call this, why our result is based on a probability? Because here we are just looking at the probability, not the absolute result. Why do we say it's a p-value? Because it's based on a sample, right? We don't know. What I'm trying to say is, you know, maybe if we take a bigger sample, then we may get exactly the opposite result. It happens sometimes. We may get, you know, something else as true. Okay, so that's why it's always based on a probability. All right. Okay, so let's go a little bit in detail of this. So if p-value is greater than 0.05, then your null is true, and if it's less than, then your alternate is true. Now, where does this 0.05 come from? Nobody asked me that. Okay, so when statisticians came up with this, let me tell you a little bit about where does the 0.05 came from. Now, when statisticians came up with this, they said that if it's, so how do we get that 0.05? It's 1 out of 20 shots, or one experiment true out of 20 experiments, or 1 out of 20 shots or 20 experiments. That's where we get the 0.05. Okay, so I'll repeat it. Most of the statisticians felt that if it's 1 out of 20 shots or one experiment correct out of 20 experiments, then that will be a 0.05. And most of them felt that if it's greater than 0.05, then they should favor the null. And they said that, so this was a rule concluded by the statisticians, that if it's less than 0.05, then we should be accepting the alternate hypothesis. Okay, so this is where we get the 0.05 from. Okay, now if I ask you today, which hypothesis is true? So let me just take off this. So guys, which hypothesis is true when we have p-value greater than 0.05? You'll still be able to tell me because we have just discussed about this, right? And again, if I ask you which hypothesis is true when it is less than 0.05, you will still be able to tell me that it is alternate, right? Because we have just completed the concept. Now, if I ask you after a few weeks or after a month, I don't think so many of you will be able to remember. Okay, now you will not be able to remember. Maybe I'll just do the summary next week and you may not be able to remember. Now I'll tell you about a small incident. So I also used to get confused between, if the p-value is greater than 0.05, which hypothesis do we select? Or if it's less than 0.05, which hypothesis do we select? I always used to get confused with this. Okay, and what happened was, when I was working in Honeywell a few years back, I got an interview from this HSBC. I mean, most of you who are from Bangalore, you would know HSBC, which is located on Banarkata Road. So the Honeywell office and the HSBC office, they are located very closely. Yes, kind of opposite or very close to each other. Arjit knows about it. And I think, Arjit, did you work in the Accenture, which is behind Honeywell, near that Delmia circle? Or are you guys, I mean, Kavya also, are you guys from that, which is near that dairy circle? Or behind Honeywell? Yeah, near HSBC, correct. IBC Knowledge Park, yeah. Okay, now, while I was working in Honeywell, of course, now the Honeywell office is not there, they have moved. So when I was working, I got an interview from this HSBC, and because it's so near, just 5 minutes away, during my lunch break, I just wanted to give this interview. It was not that I was not happy at Honeywell, but I just wanted to give so this interview was for a manager black belt. I was already working as an AM, as an assistant manager, OPEX or Operation Excellence. So I think even in Accenture, you guys call it as Operation Excellence, same thing in Honeywell. So I wanted to give an interview to see in terms of the knowledge of Lean Six Sigma, where do I stand in terms of knowledge of Lean Six Sigma. So I went for this interview and I was just revising. I was just sitting in the lobby over there. I was waiting for the interviewer to call me. Now, while revising, I thought about test of hypothesis, and I always used to get confused which hypothesis to choose when the p-value is greater than 0.05, and which one do I choose when it is less than 0.05. Okay, so what happened was, while I was revising, see, during those times, smartphones were not common, right? So I just called up one of my friend who was working in Accenture. Her name was Sangeeta. I mean, she's quit by now. So I just called her up, and she was working as a band C or band D over there at that time, almost my same position, band C or band D. So I just asked her, hey, Sangeeta, it's like, phone a friend. You're just calling your friend and you want to know the correct answer. So I just said, can you tell me which hypothesis? Can you Google and tell me which hypothesis is true if the p-value is greater than 0.05. So she was also a little bit confused, and by the time she could Google and give me the right answer, the interviewer called me inside. So I missed that opportunity of knowing the correct answer. So when he called me inside, to my, as I expected, he asked me the test of hypothesis question, because it's an interview for a manager black belt. This is a sure question. Okay. So when he asked me the question, can you tell me which hypothesis is true if the p-value is greater than 0.05? I was confused. I thought a lot. And finally, I said, it's the alternate which is true. And this guy was a master black belt. I don't remember his name, Sam Khurana, a very jovial guy, very funny guy. So he said, Aisha, are you sure? Again, I thought for some time. I said, yes, I'm sure. Then he said, lock kiya jaye? I said, yes. I was very confident. I said, lock kiya jaye. And then he said, Aisha, unfortunately, you have given the wrong answer. Okay. So that's a time. So this guy was very sweet, and he gave me feedback on the spot. He said, you are good, but you're not yet there. You are not very good. You still need to, go a long way. So he said, haven't you heard about a clue called as if p-value? So he gave me a beautiful clue to remember. It's a very famous clue, which some of you may already know. So he said, haven't you heard about a famous clue that if p-value is greater than 0.05, so if p is, okay, if p is high, then null will fly. Okay, sorry, he gave me the other clue. So he gave me if p is low, then null will go. So you need to be careful with the meaning of go over here, not go ahead. It is ruled out, not applicable. Okay, he told me, haven't you heard of this famous clue which says that if p is low, then null will go? So I'll just explain this to you. Okay, so what is the meaning of p is low? That means p is less than 0.05. P is low, less than 0.05, then null will go. Be careful with the meaning of go. It's not null will go ahead, null will be ruled out. Don't you think this is an easy clue to remember which hypothesis is true? Yes. So if p is low, they are rhyming, null will go. And trust me, it's been so many years, I've never got confused with this rule from the time I have picked up this clue. Okay. So there's another one similar to this. Just the other way of putting this, it's like there's one more. If p is high, then null will fly. When we say fly, null will be applicable. So either ways, you can choose any one of this, whichever is easy for you to remember the rule. Okay, so it's up to you which one you want to pick up. So if p is high, so when we say p is equal to p is greater than 0.05, then we'll pick up the null and null will be applicable. Okay, now there is one question from Lalit. What if p is equal to 0.05? So Lalit, see, Minitab either gives you greater than or less than. I have never come across equality. It'll be slightly above or slightly below. But in case if you ever come across a condition where p will be equal, then just go ahead and repeat the test. Maybe there is something wrong with your sample or something like that. Okay, so guys, isn't this a good clue to remember? Right? So I can just put it in the notepad. So if p is low, then your null will go. And if p, okay, clues to remember the result interpretation. This is how we interpret the result. Yes, so I put both the clues. Whichever you find easy to remember, you can choose that. Okay, now what we'll do is, with this clues in mind, let's proceed. Okay, Kavya, there is a way to do this test of hypothesis even in Excel. Okay, so unfortunately, I'm not using the version which is like latest version, but what you need to do is you need to install that data analysis tool pack. So once you install that data analysis tool pack, you will find test of hypothesis over there. It's very simple, Kavya. What you need to do is take the two data in two columns in Excel and then follow the steps, very simple 1 or 2 steps, and then do the test of hypothesis. Go to test of hypothesis in the menu. Once you add the data analysis tool pack, you will have it, and p-value will be automatically calculated by Excel. That's all. It's very simple. Select the two data columns, it will give you the p-value. And based on the p-value, it will give you the result. Sure, Arjit. What I'll do is, yeah. Arjit, just give me 1 minute. I have Minitab as of now, but I don't have, I mean, I will not be able to show you in Excel because this is a very old version. I don't know how long it will take to add that data analysis tool pack or whatever. Okay, so guys, what we can do is we can shortly take a break. So during the break, I will just see if I can install the data analysis tool pack, and if it's installed successfully, I'll show you in Excel. Otherwise, I can show you in Minitab. Will that be fine? Okay. All right. Now, before we go for the break, so I don't want to break the flow. So what we'll do is, just give me 5 minutes. What we'll do is we'll proceed with the conclusion now, and then after the conclusion, we can go for a small break of maybe 10 minutes. All right. Okay. Now, so far we have seen the p-value, right? So we interpret the result with the p-value. Let's go by step and now interpret. Now, since we know how to interpret the result, let's go step by step and interpret the result for our data. So let's go step by step. So this p-value, is it greater than or less than p-value? Sorry, less than 0.05. So you may be thinking Aisha is asking such a basic question. So why am I asking you this basic question? Because sometimes people get confused with the decimals. So this p-value, is it less than or greater than 0.05? Let's go step by step. Yes, it is less than 0.05. So when it is less than 0.05, which hypothesis do we select? Yes, because it's less than, if P is low, null will go, null will be ruled out. Correct? So you need to select the alternate hypothesis. Okay, now scrolling up. If your alternate hypothesis is true, then who's correct? Is it me or is it Arjit who was right? Yes, so Arjit was favoring the alternate hypothesis. He said that there is a significant difference. So now coming to the practical action, what do we do? Can we close the project or should we rework on it? So I told you the practical action is very, very important. Last week we discussed about it. Yes, because there is a significant improvement. The new training program is much better than the old training program. Yes, correct. So we have been successful in improving the quality program. The new training program is much better and we can actually close the project. And we can continue with the new training program. So that's also important. Post closing the project, we need to deploy the new training program everywhere. Okay, so this is the way you give a step-by-step conclusion. All right. Okay, so next, what I'll do is I will also show you how do we write this conclusion before we go for the break. So we just talked about it, but how do you write? There is a way in which you have to write a conclusion. I will just showcase that to you. One minute, guys, just give me a minute here. So this is the way a typical conclusion is written. Yes. So this is the way a typical conclusion is written. The t-test outcome was a p-value of a 0.001. So we know that by convention, the interpretation is that a p-value less than 0.05 means that there is a statistically significant, you can see the word statistically significant difference between the two groups of data. So we can therefore safely conclude that the after process is producing a higher score. Yes, and a difference of 17. It's not a percentage, and a difference of 17. So the after process, what is the after process? The new training program, correct? Is producing a higher score, and a difference of 17 in means is very likely to be the result of common cause variation. Okay, so this is the way the conclusion has to be written. Okay, now let's go back to our notepad and just complete this. So now it's very easy to go through the roadmap. So initially we had the two hypotheses, that's myself and Archit, favoring the null and the alternate. Then we had the scores, and then we did the test of hypothesis. I'll just put it in Minitab or Excel. And then how did we interpret the result based on the p-value? Yes, and finally we got the alternate was true. Finally, we concluded whether that the alternate was true in this case. Okay. Okay. So guys, I don't want to put too many things on your head. So you have been quite good in understanding the test of hypothesis so far. So what we'll do is we'll take a short break of 10 minutes for tea, coffee, and then I'll come back. I'll just summarize the entire test of hypothesis once more, whatever we have learned, because this is a first time for you. So I want to come back and summarize and then go to the next topic, because it will be a little bit too much if I continue now. Okay, so we'll take a quick 10 minutes break. It's about 1:20 now, and we'll be back at 1:30. So like I said earlier, I have a hard stop at 2 today. So we'll continue after the break for the remaining half an hour, and we'll wrap up at 2 o'clock. So next week, we'll keep you informed about the timings. Whatever it is, the timings the next week, but it'll be for 3 hours. So we'll be completing, next week will be the last class for 3 hours, where we'll be completing the rest of the topics like control charts. We still have to do control charts and DOE, design of experiments. Sure, Piyush, I can do that. It'll be on a Sunday. I mean, what is your preference? I mean, I'm okay with anything. You guys, we can go ahead with the majority. I'm okay with anything, Saturday or Sunday. You guys tell me. If most of you are for Saturday, then we can do it on a Saturday. Sure, then I'll inform Saurav accordingly, so we can schedule on a Saturday. Okay, so guys, I'll go with the majority. Sorry, Rekha, I mean, okay. Yes, so whoever hasn't put Saturday or Sunday, okay, yeah, please don't have dual entries. I mean, whoever hasn't put Saturday or Sunday, I just request you to put Saturday or Sunday, like Arjit says. So we will go with the maximum. Okay, the rest of you can also put your choice, and I'll ask Saurav to look at it. And so I'm okay with anything. Okay, so anyway, guys, you can put it during the break. So let's take a quick break and let's come back, say in another 10 minutes. Okay, so till then I will just keep the screen like this. Thank you. Okay, guys, so I hope everybody is back from the break. Okay, all right, so we'll continue. Guys, just wanted to let you know about one problem. So the power at my home is gone just now during the break. And currently, so I have a broadband and currently I'm hooked on to my phone's, personal hotspot. Okay, so I don't know, my phone is also, I mean, as you know, when you use the hotspot, it's like the battery goes very low very soon, it gets over. So I don't know how long it will last. So whatever it is, till it lasts, we can continue, and then I'll make up in the next session. Okay, to be precise, we have to do the session for about 25 minutes, but I'm not sure whether it will last for 25 minutes. Okay, so I'll try my best to complete or conclude on the test of hypothesis, and then I'll continue with the rest of the topics. So we had certain topics to be covered today itself. That's project selection and team member selection was one of the topics. How do you select a project and how do you select the team members? And we had to discuss the Poke, that's the lean tool of the day. So if the current comes, I'll continue with it. Otherwise, I'll continue in the next session. Okay, now quickly concluding on the test of hypothesis. So let's quickly summarize on the test of hypothesis because I don't want you to guys, just 1 minute. My daughter, I'm not sure whether you're able to hear her in the background. She's just talking very loudly, so I'm not sure whether you're able to hear her. Okay, so we will conclude on the test of hypothesis. So first of all, the test of hypothesis. So just want to check, one of you, can you confirm whether you are still able to hear me? Any one of you can confirm? Okay, thank you. Just wanted to make sure that this connection is fine. All right, so to summarize on the test of hypothesis, so I want everybody to pay attention. In another 5 minutes, I'll just be concluding on the test of hypothesis. Okay, now the test of hypothesis we know is one of the complex tools of the analyze space, right? So we know what is a hypothesis. We know that it's an assumption or a theory, and it may be true or it may be false, and we have to do the test of hypothesis to prove it, right? Based on the data, we prove whether it is true or false, true or false. Now the roadmap everybody understands. So first we will have a hypothesis, and then we will have some data collected, then we'll perform the test of hypothesis, interpret the result after that based on the p-value. So we'll go by these steps. We'll form the two hypotheses, we'll collect some data, perform the test. Based on the p-value, we'll interpret the result, and finally we'll conclude which hypothesis is true, whether it's the null or the alternate, and then take the practical action accordingly. All right. So in our case, we took the example of a GB project, which was done to improve the quality of a training program, the new training program, which we came up with after improving on the old training program. Now, in this case, we said that the null states, I mean, it's always that the null states that there is no significant difference between two samples of data. So it always stands for equality, and the alternate always stands for a significant difference, right? So it stands for a difference. All of you know about that. Now, we also learned what is a significant difference between versus a mathematical difference, correct? So we also know that. And in our example, we took both of us, that is Archit favoring the alternate and myself favoring the null. And I showed you how to interpret the result. Next, I also gave you clues to remember the result interpretation, right? So we told that if P is low, then null will go, and if P is high, then null will fly. All right. So at the end, I will be sharing this link with you, and let's see whether we can complete the two topics today itself. All right. Now, next, I wanted to do a small concept, a concept which remains under the test of hypothesis. So just give me 1 minute. I'll go to my Excel sheet. Now, the next concept is about the confidence level. So I told you that these tools work on the probability, right? Because we are just taking a sample over here. So what do you think, what do you understand by the confidence level? Okay, now suppose I say that the confidence level for this test is a 95%, then what do you understand by this? Suppose I tell you that the confidence level for this test is a 95%, then what do you understand by this? Okay, so maybe I can just put it in Excel. Now suppose I tell you that the confidence level for the test we just performed is a 95%. So what do you understand by that? Yes, exactly, right? Like all of you said, we are saying, so the meaning of the 95% confidence level is that with 95% confidence, we can say that in this case, it's the alternate which is true. Correct? Exactly. So all of you have understood it. Yes, exactly. So confidence level of 95% means that with 95% confidence, we can say that the H1 is true in this case, in this example. Correct? Now, what is the error or the risk which we are taking over here? What is the risk or the error which we are taking over here? Okay, so that means to say, so if we are saying that with, so confidence level, like we said, of 95 means that with 95% confidence, we can say that the alternate is true, but still we are taking a risk of 5%. Yes, so let me look at the chat, like Anup says, and yes. Okay, so Arjit, it's very simple. So what we are saying is the risk or the alpha or the error, or so guys, first of all, how do you calculate this risk? How did Anup say 5%? Yes, so it is nothing but 100 minus the confidence level gives you the significance level. Okay, so this is the formula. So it's nothing but 100 minus the confidence level gives you the significance level. Now I want you to just pay attention for a minute here. Now this risk or the alpha or the error or the significance level, it has 4 different names, 4 alternate names. So be careful, in the exam they can ask you with any one of these names. The question can be with any one of these names. Okay, it all means the same. So they can ask you what is the risk or the alpha or the error or the significance level of this. It is, so 100 minus the CL, 100 minus 95. So we'll go step by step. So it will be 100 minus the 95, that will be a 5% risk. Okay, so this is how we get. On the other hand, so you know the formula. So let's do some practice in terms of, so if the confidence level is 95%, you know that the risk which we are taking is a 5%, correct? You understand that? Next, Now, suppose I decrease the confidence level to a 90%. Then what is the risk which we are taking? Yes. So when one decreases, so in this case, I've decreased the confidence. So what happens to the other? The risk increases. The risk which we are taking is increasing over here. When the one decreases, the other one increases. Yes. So you know the formula remains the same. It is nothing but 100 minus. So 100 minus CL is the significance level. On the other 100 and 100 minus the significance level gives you the confidence level. Okay, so in the exam, when they give you one of them, you can always calculate the other one. Okay, so when the confidence level decreases, automatically the risk we are taking increases. Okay, now next, coming to the default values. So what are the default values? So whoever has used Minitab, yes, so the default confidence level in Minitab is a 95. I'm not sure about other softwares, but the default confidence level in Minitab is 95 unless you change it. Okay, so what I'll do is I'll put all this into the notepad so that you can remember it. I'll put all this formula. So if confidence level for the test is 95%, it means with 95% confidence, we can say that the alternate is true in this example. Correct? So I've just given the table. Formula is here. Yes, and we know that when one increases, the other one decreases. Right? Okay, now let me see if I have any questions on this. Yeah, so that will be helpful. So as long as I put it in the notepad, you guys will be able to see this and you can relate back to it. All right. Okay, so I hope everybody got this confidence level and a significance level. So remember one thing, you have to remember that in the exam, they can ask you with any one of these words. It means the same thing. Okay, now the next concept is maybe quickly I will share the link for. Okay, maybe Arjit, I will share the video for that one more example, that p-value calculation example. I want to share the video before my connection gets off. So I just request that I will share the video link now, but I request you to watch it after the class because during the class it will be disturbing. I mean, you will not be able to catch up with what I'm saying. Okay, so before the connection gets, my phone battery goes absolutely low, I'll share the link with you soon. So once you watch the video, maybe yet another example, it will be more clearer for you, Arjit. Saurav, this p-value is universal. Again, the conclusion is universal, but it is purely dependent on your data. So it doesn't, it actually takes care of the common causes. Sure, Arjit, you can do that. Please go ahead. You can unmute yourself. Let me know if you're not able to do that. I'll unmute you and you can ask.
No, I did that. I did that, Aisha. Thanks.
Okay, Arjit, just that I'm experiencing a slight echo in what you're talking.
Now it
Not
should be
sure
fine. Now it should be.
if else.
No, I changed the settings, so probably that was the
Yeah, now
reason it
it's
was
clear.
like. Okay, now as you put this confidence level of 95% example a couple of minutes back, I just want to understand how you get this 95% confidence.
Okay, so let me see if I have a picture for this.
Okay, and now so the second point is, and how this 95% confidence level is the H1
Okay,
or the
that is okay.
alternate.
This is a good question. See, in this example,
Uh-huh.
going back to the example of this particular data. In this
Okay,
case, our H1 was true. So
correct.
I think that's where you have got confused. So I just asked the question that what do you mean in this example? What do you mean when we say we did this particular test, which we just completed, the example of the training program? If in this case, if the confidence level for this test of hypothesis was 95%, then what does it mean? In
Okay,
this case,
okay,
we can say that, you know, we can say that with 95% confidence, we can say that the H1 was true. But in some
okay.
other
This
case,
is this is basically a notation, is it? I mean, once you have found is true, you can tell that the confidence level for the test is 95%. Is it like that?
correct, correct. So what I'm
Okay.
trying to say is it varies. So it could be for a null also in another example.
Yeah,
See,
yeah,
whatever
absolutely.
the conclusion is, whichever is correct, whatever is your conclusion, whether it's the null which is true or the alternate, you are saying that with a confidence of 95%. And still there are 5% chances of the other one being true. There is a risk
Yeah,
of 5%. Okay, so now I think that was your confusion. In this example, it is
absolutely.
alternate which was true. Okay,
Great, Aisha. That was
it
really
is solved.
helpful. Thanks, Aisha. I'll mute myself again.
Sure, sure. Thank you, Arjun.
Thanks a lot. Thanks a lot. That was really helpful.
Okay, thank you. Okay, next, moving on to the next question. Yes, so Anup, we can also link the p-value with the normality test. Okay, so Anup, I mean, although we even in normality test we still use the p-value. So I didn't want to confuse everybody over here. Maybe Anup, just for you. So when we do the normality test, what do we conclude? It's the same conclusion, right? If the p-value is greater than 0.05, again, so guys, what I'm trying to tell is something called as normality of the data to check whether the data is following the normal distribution or no. So maybe I just have a small table over here, Anup, which I can share with you. Okay, so Anup, what I'm trying to tell is, so guys, I don't want to confuse everybody, but there's another test called as normality of data. So what do we mean by this normality test, or I can call it as test of normality? You guys would have heard about it. Now, what does this test of normality do? It concludes whether your data is normal or no. Okay, that's what it does. It concludes whether your data is following the normal distribution or no, right? Now, in that case also, we rely on the same p-value. So there are many tests in statistics in which we rely for our result interpretation on the same p-value. So that's where Anup is having this question. So in case of normality test, when do we say the data is normal? If your p-value is greater than 0.05, then we say it's normal. And if it's less than 0.05, then we say it's not normal. Okay. Same way in case of test of hypothesis, you know the conclusion. Yes. So maybe I'll just quickly show you how to do this. Anybody else who's aware of this normality test? Heard about it? It's just to check whether the data is following normal distribution or no. Okay, so what I'll do is let me try opening Minitab and quickly show you that. how to find out in Minitab whether the data is normal or no. Yes, so I've just opened Minitab, and again guys, this is not a part of our curriculum, I don't think so, but still it is very useful, so I'll just give it to you. So I'll just put a data set over here, a simple data set. Okay, maybe I can just copy paste from the data which I already have. So I'm just taking some dummy data, 10 values, a set of 10 values. I want to just see whether my data is normal or no. Is it following the normal distribution or no? So it's very simple. What I need to do is go to stats. Under this basic stats, can you see a small icon called as normality test? Next to that normality test, a bell curve shown there. To see whether if you read the notes over here, it determines whether your data follows a normal distribution or no. So click on that, select the data which is in column C2, that's all. You just have to say OK. Okay, it gives you a plot. And how do you conclude whether this data is normal or no? It's very simple. Yeah, so Chitra, it's very easy. Like I told you, Minitab will calculate a lot of things like it is. We didn't ask it to calculate the mean or the standard deviation or something called as actual deviation. So it will calculate everything. But we have to base our conclusion primarily looking at the p-value. So that's where Anoop's question was from. So he wanted me to tell the relationship between the p-value and the normality test. Good question, Anoop. So in case of normality test also, we use the same p-value. If the p-value, so in this case, it is greater than 0.05, the value, correct? So we can conclude. What is the conclusion? In this case, it is greater than 0.05, so the data is normal. Okay, so in many tests, we actually make use of the same p-value. So it's as simple as that. Piyush, let's not conclude the null hypothesis over here, because null hypothesis is not there here. What I'm trying to tell Piyush is like the same p-value is used in different tests for making the conclusion. But you don't really have a null hypothesis in this case. You just have one set of data, that's all. Okay, it's the same p-value which is used in different instances. All right, okay, so I think everybody got the concept of this confidence level and the significance level. So I think we are almost going to be closing. So guys, what I'll do is, since we didn't get the time, we will continue with these small concepts. I had just 2 small concepts to complete. So we'll continue in the next week with this. Okay, so now just give me 1 minute. I'm just searching for that link for you. I'll just give it to you in a minute. Just request you to be online. I'll just search the link for the p-value calculation and I'll share it with you. Have you guys heard about something called as Khan's Academy? An academy started by Salman Khan, not our Salman Khan. So this video is actually from Khan's Academy. This is a very good site. So in case any one of you want to learn about things like confidence level, want to know some more details, it's a very good site. Okay, so I've got the link here. Just that I wanted to open it in Google. 1 minute. Yes, so here's the link. Sure, Kavya, I'll do that. Okay, so guys, you have the link. And then just give me 1 minute. I'm just responding to one of the chats. All right. So I have the link over here, and I think we'll stop over here, guys, because today I have to, I have a hard stop at 2 o'clock. So we'll continue next week. So we will give you updated on the schedule of the next week. So we'll continue and we will finish off the rest of the topics. So we still have our control charts, and then we have our DOE and 1 or 2 small topics. So thank you very much. And you can go through this link and try to understand the p-value calculation. All right. So thank you very much and have a good rest of the week. Have a good Sunday evening, and I'll see you next week. I think most of you will be traveling. So in case if people are traveling, safe travels, and I'll see you next week. Thank you.
Thank you, ma'am. Great session.
Bye-bye. Thank you.
Thank you, Aisha.